again and form HCl. But strong acids do not want to form HCl. They want to stay broken apart. So if I did this accurately, I would actually just draw one forward arrow like that, and I wouldn't draw any reverse arrow at all. That's the correct way to write it. That means all of the stuff on the left broke up and formed the stuff on the right. None of these things want to join back up together again and form HCl again. You're going to see how that's different from weak acids in a second. Okay, so you're welcome to do your second arrow like that. So just a one-way forward arrow, it's like a little half an arrow, okay? But no reverse arrow. So even though this is a reversible reaction, just like this and at the top, most reactions are reversible in fact, it's not actually going to reverse. It wants to stay broken up. Okay, it's nice to draw little pictures with these definitions because when you learn them, it doesn't make much sense until you like visualize it. Okay, so that's strong acids. Strong acids ionize, listen to the definition again. Ionize completely, break up completely, and form a high concentration. So let's write here. There's a high concentration of hydroniums. How high is the concentration of HCl molecules? How high is the concentration of H0? Because it doesn't want to stay HCl. It wants to break up and it wants to form ions. Okay, then let's write down the definition of a weak acid. Okay, weak acid is here, weak acids. Ionizes partially in water to give a low hydronium concentration. Okay, weak acids here. You can write down that definition for a weak acid. So weak acids ionize partially in water to give a low hydronium concentration. So let's do an example of that. So they ionize partially in water, in other words, not completely, and they give a low hydronium concentration. So let's take a weak acid. Let's take one we don't work with a lot. Let's take acetic acid. Okay, sorry, let's write the heading weak acid. Okay, so you've got your weak acid, you've got your definition, plus water. Okay, so what is acetic or ethanoic? Same thing, it's just a different type of word. What does it break up into when it breaks up? What does that CH3COH break up into? You learned one of the compound ions, so you should know. Yeah, CH3COO minus and H plus, that's what it breaks up into. Okay, so at the moment I'm going to make my arrow reversible, but maybe you want to leave it for now and then you can do it when I've done it properly. So this is going to break up, so immediately it's going to break up into this and this. But what does the H want to do? It doesn't want to be by itself. Okay, it's unstable, it's not happy, so what does it do? It joins with the water, and immediately it forms hydronium ions. Okay, so we're not going to write that little first step anymore. We're just going to go straight in and say, look, this is going to bond with this straight away and form hydronium. Plus, what is this ion called again? The CH3COO minus. Think about the acid's name and then think about the ion's name. So acetic acid, the ion is acetate. Yeah, it's the acetate ion. Okay, so this is what forms here. So this breaks up with water and it forms this and this. Now, help me with the arrows, because the definition says it breaks up partially. So if I had to draw this, maybe let's draw it first and then you can help me with the arrows. Okay, so if you had a beaker of acetic acid dissolved in water, you would see a lot of what? What would you see a lot of in the beaker if you could see the particles? You'd see a lot of that. Okay, you'd see a lot of CH3, COOHs, a lot. And then you would see a couple of hydroniums, and you'd see a couple of CH3COO minus ions. Why? What does this acid not want to do? Doesn't want to break up. Okay, weak acids don't want to break up. Okay, so you'll see a lot of the original acid and you won't see a lot of this stuff. So what do you think I must do to my arrows? Which arrow must be long and which one must be short? That's the forward arrow, we call it. The forward arrow, and this is the reverse arrow. Okay, so which one do you think needs to be longer, the forward arrow or the reverse arrow? Nice. Okay, the reason for that is this reaction doesn't want to happen. It doesn't want to break up. And even if it does break up, the particles will then go, don't like this, and they'll join back up together again. Okay, so your reverse arrow is much longer than your forward arrow. The particles don't want to break up, and even if they break up, they want to join back up together and form the acetic acid molecules again. These are weak acids. Weak acids don't want to break up. They want to stay as like whole molecules. Okay, so what do we know about the hydronium concentration? Is it going to be high or low? Yeah, very low. Hey, low concentration. Do you know what another way is to write this? If you don't feel like writing all these words out, easier just to, you can write this. The square brackets mean concentration. So you can do that in a test, by the way. Okay, instead of writing this has a concentration, you can write square brackets. How that reads is the concentration of hydronium, that's right, there is low. Okay, so you can do that from now on. So you can do square brackets, and that means the concentration of something. Okay, and make sure you draw a little picture for yourself so you can get a visual of all of this. Okay, when you're done with that, your next little heading of bases. So we're going to do exactly the same thing, but with all the bases. Okay, starting with the properties. What are some properties of bases? Okay, what are some properties of bases, guys? Some common bases that we find. What are some of the properties? Anything you can think of from last year? They feel soapy. Nice. That's a good one. They feel soapy when you touch them. I don't know if this is a bit of a dirt question, but things you use every day that have a base in them. What are those things? Say again? What did you say, Diego? Not sure about toothpaste is possible. I might just not know. But soaps and detergents have bases in them. What is that common base that's often in soaps and detergents?
Hydroxide.
Yeah, it's a type of hydroxide, sodium hydroxide. So go home tonight and check at the back of your face wash or any kind of detergent and see if there's some sort of hydroxide, like sodium hydroxide in that. Okay, so that is what makes it feel, well, that is what feels soapy. Then the pH is what? Above 7, yeah. Sorry? Does soap also have an acid in it? Not that I know of. I guess they can put something in for some reason, but it doesn't need to have it in it. Like, it's not what helps. The base is what helps clean. We can write the same thing we wrote for the acids, that when you dilute a base, if bases are diluted in water, the temperature rises again. So again, you can write water plus a base gives you an exothermic reaction. Okay, and you dilute it the same as an acid, by the way. You add the water, sorry, you add the base to the water, not the other way around. You always want as little base or acid at one time. So you want a large beaker of water, you want to add a little bit of acid or base to that. The other thing you can write down, acids had all had what in them? Hydrogen ions. Bases, you can write this here. All bases or alkalis, remember alkali is a base that you dissolve in water, which dilute with water form OH ions. So what makes a base is that it forms OH ions, whereas acids form hydrogen, but we actually know even more correctly hydronium ions, right? So acids form hydrogen, which become hydronium ions, and bases, you can write down this third little bullet as well after the second one. Bases, which dilute with water, form OH ions. So bases have OH, like sodium hydroxide. Bases have OH ions in them. Then you can make a list of strong bases and weak bases like we did with the acids. So let's start with the strong bases again. Okay, so the first one, potassium hydroxide. You can actually write it straight from this list. Okay, potassium hydroxide, KOH. And tell me if you notice anything about your strong bases. Like if you've forgotten a test which ones are your strong bases, what could you do? Let's look at a couple and then you can tell me. Okay, so potassium hydroxide, also called potash. Okay, another one is sodium hydroxide. And write down these common names. Again, nothing is preventing them from in a test asking you what is potash or what is caustic soda. Okay, so this is the one that's oftentimes in soaps, sodium hydroxide. Okay, another one is calcium hydroxide. When you study for a test, read through these tables of where you use these acids and bases. They could ask you something like that, like a little 1 mark or 2 mark question about where do you use this or what do you do with this in everyday life. Okay, magnesium hydroxide, you can write strong. I've made a note here, but just ignore that. Okay, you can write that's a strong one as well. Ooh, actually, before I show you that one, do you know where magnesium hydroxide is used? Sorry, I don't know if anyone saw that. Magnesium hydroxide, it's something, okay, so at night you've eaten too much and then you take something afterwards to help. Antacid, yeah, like Gaviscon or Rennies or Eno or something. Why? What does that do? Yeah, it's basically tries to neutralize the stomach acids. Your stomach has made too much stomach acids, so you start to feel heartburn, you start to feel uncomfortable. Okay, so magnesium hydroxide or milk of magnesia, that's why they call it that. Okay, so antacids have magnesium hydroxide in it to try and neutralize stomach acid. Okay, it's also a strong one, like I said, so just ignore this note on the side. Okay, then let's go on to some, sorry, is everyone done with that? Some weak bases. Okay, so you can write a little heading weak bases, and there's 4 there. So sodium hydrogen carbonate, which is baking soda. If you bake a lot, you'll know that that's sodium hydrogen carbonate. Then sodium carbonate. Again, write the little common name for yourself just in case. Then calcium carbonate and ammonia. Okay, write those 4 down under weak bases. Yeah, sorry? Sorry, magnesium hydroxide.